Hi and welcome to a lesson on rate law and order of reaction. Rate law is an equation that relates rate of reaction to the rate constant and concentration of reactants raised to some power. Next, you must also know that the rate law is known as rate equation. Now, let's look at the general chemical equation given. Rate law is written as rate equivalent to K, which is the rate constant, multiplied by concentration of A raised to the power of X and multiplied by concentration of B raised to the power of Y. You must take note that the rate law or the rate equation only contains reactant species. Next, X and Y is known as the order of reaction. X is the order of reaction with respect to A, whereas Y is the order of reaction with respect to B. You must take note that X and Y is not equivalent to the stoichiometric coefficient, which is A and B. X and Y, or the order of reaction, is determined experimentally, and sometimes maybe these values can be the same as stoichiometric coefficient A and B. But this does not mean that we have taken the value straight away from the chemical equation. Next, let's look into the overall order of this reaction. It would be X plus Y, since overall order of the reaction is the sum of power of concentration of reactants in the rate equation. Now let's move on to an example. Here, the chemical equation is given to you and the rate law is also given. Take note that the rate law only includes the reactants present in the chemical equation. Notice how that there are 3 reactants present in the chemical equation. However, there's only 2 in the rate equation. This is not a mistake but a good indication that one of the reactant species is zero order. That means the concentration does not affect the rate of reaction. This question requires you to determine the order of reaction with respect to each reactant and overall order from the rate law given. Since there are no powers written on top of the concentration of H2O2 and I-, it means it is raised to the power of 1. Therefore, the reaction order with respect to H2O2 is the first order, and this would be the same for I-. The concentration of H plus is not present in the rate law because anything to the power of 0 would be 1. Thus, the reaction order with respect to H plus is zero order. This means that the concentration of H plus does not affect the rate of reaction. Now to the overall reaction order, which is the sum of power of concentration of reactants in the rate equation. 1 plus 1 plus 0 would give us second order. Now let's try out another question on order of reactions. Here, the chemical equation is given to you and it is said that the overall order of the reaction is given to be second order. You are required to write out all possible rate law. Now let's begin by writing out the general equation for rate law. That would be rate equivalent to K multiplied by the concentration of reactants raised to a certain power. The reactants we have is A and B, so that would be concentration of A raised to the power of X and concentration of B raised to the power of Y. Let's look into the possible combinations that can produce an overall second order. One option would be both A and B having the first order reaction, and that would give us an overall second order. Next, we can have a second order of reaction with respect to A, but a zero order reaction with respect to B. And the final combination, you can guess it, it can be zero order with respect to A and second order with respect to B. And there you have it, all possible rate law for this question. That's all for this video. See you in the next. Thank you.